Okay, I want to do a quick review of my space-time superposition chart. Now this chart is the first layer of a three-dimensional structure that I would like to call my light superposition cube. It's basically, if you take this chart and lay it down flat on the ground, and then you take a second chart and lay it on, stack it on top of it, and a third chart and stack that on top of it, you would basically have three charts, which each layer having 9 dimensions. And three-dimensionally, it would represent a cube with 9 dimensions on each layer. So it's a three-dimensional structure where the bottom layer is my space-time superposition chart, and that's the chart you're looking at now. And that's what I want to talk about. I don't want to talk about the upper layers yet. This video is primarily going to focus on the bottommost layer of my light superposition cube. So the bottommost layer of my light superposition cube is called my space-time superposition chart, or space-time superposition chart. This is part of my theory, which I've titled Greaux' temporal theory. And basically the theory shows that the missing link in physics today is time. Physicists don't seem to have a grasp of what time is, and I only have an idea simply because this chart started me on a journey. As you saw in the last video, how I made the chart and how I discovered or realized the chart. But it started me on a journey years ago, and now I'm on the third chart, which is the last layer of of a structure within reality that seems to define the interactions of matter, space, and time. That's just the only way I can describe it. But in this video, I want to focus on my space-time superposition chart, which is the bottommost layer, because in order to understand the upper layers, you have to get a good understanding of the bottom layer, which is what the upper two are built upon. And speaking of that, speaking of built upon, this chart here, all of the 9 dimensions on here are built upon the dimensions that come before it. So if we start at the very beginning, which is the first dimension, which I've titled latitude thread, everything else is built upon this. If you think about it, three-dimensional space, we have what I call a latitude vector, or not a latitude dimension, where things are aligned vertically. And if you take that dimension and you flip it on its side, which is what I call a horizontal flip, you will get the second dimension, which is the longitude dimension. And in Euclidean space, you have three-dimensional space, which the first and second dimension, and it produces, if you put the first and second dimension together, you get a two-dimensional space. But really, there's no such thing as that, because when you put the first and second dimension together, it produces a third dimension automatically, which produces a neutral position. I think that happens in nature. So, from my years of studying and looking at this, there's no such thing as two-dimensional space. I mean, you can have a two-dimensional plane where you have a piece of paper and you're drawing on it in 2 dimensions. That's not what I'm talking about. I'm talking about in nature, the natural processes that produce this reality that we know. When you put the primary position and a secondary position together, you automatically produce a third or tertiary position, which includes the first position, the second position, and then it also includes a neutral position. A neutral position shows up when you put the first and second positions together. So that's why we have the X plane in the latitude thread, and then the Y plane in the longitude thread, and then we have three-dimensional space, which a Z plane shows up. Now people say, I had someone tell me that, Euclidean space doesn't label the X and Y and Z plane like that. The Z axis is actually facing up and down, and A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. I learned that in kindergarten. X comes before Y comes before Z. One comes before 2, 2 comes before 3. So if one process is going to be built on the other, I'm going to start with the lowest one, which is X. And if Y is going to be built on top of X, I'm going to put Y next. And then Z is a neutral position, which comes after X and Y. So I'm going to put that as Z. So Euclidean space is X, Y, and Z. I mean, that's just common sense. But, I don't know why they labeled it the other way, but I'm not going to get into that. I labeled this way, and I'm not changing it. And that's because everything is built on what comes before. And it's easiest when I label these things in the proper order, because all these other things are going to come after that. So, and you need to see these planes, because later, especially when I look at when you start seeing the other stacks, you'll understand why it has to be this way. So I'm not saying change the normal physics and how they teach people stuff, but in order to understand this theory, you have to go by X, Y, and Z, 1, 2, and 3. There's a sequential order in nature. Nature has a sequential order, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything's built on what comes before. You find that in nature. Everything in nature comes in threes. So I started with X, and then we came with Y, and then Z, and then we go in reverse. We have to show you on the time column, we have the all three of them, the Z plane at the fourth dimension, and then we go to X plane, and then Y. So you see that these things, they change order in the way they're positioned. But we're going to get it. I don't want to jump the gun. We're getting into that later. So I want to say that the latitude thread is the primary position. The longitude thread is the latitude thread. They are the same thing. It's just in a different position. What these are showing you, that these are different dimensions of space. Space is compartmentalized. There is no single space, and modern physics seems to look at the universe like there's just a single universe with one space, and that is not true. There's too much evidence showing that there is more than one space. And we see the interactions with light and other matter showing that these particles are going in and out of this part of space, the part of space that we interact with. And the thing about it is that the matter in our body is really interacting with more than one space. See, space as a whole is not a single space. Matter itself occupies more than one space. And it's time that is determining the interactions between these particles of matter. Time is what causes, I don't want to give too much information about my other higher charts, but time is responsible for a lot of the interactions with matter in space. And you can see a lot of the interactions. Even just looking at inertia, when you're driving a car and you step on the brakes, your body wants to keep moving forward, because all motion is caused by the flow of time. Everything, all motion, any movement in space is caused by the flow of time. So when you in your car and you step on the brakes, something is, this is really not a force that says there's a force that's pushing you or pulling you forward as the car tries to stop. Your body wants to keep going forward. And That effect is no different than the effect of gravity. Gravity and inertia they're all the same thing. They're all time operating in different dimensions. Gravity itself is time being compressed into a singularity. And because our bodies are interacting with time, that's what's causing us to stay on the ground. If I jump up in the air, gravity pulls me back down, but it's really the compression of space-time that's bringing me down. And so inertia is operating the same way. When you're in a car and you're moving at 60 miles an hour and you step on the brakes, your body wants to keep forward because there's a dimension, which is the ninth dimension, that's causing me to want to keep moving forward. And that's the decompression of space-time. And decompression of space-time is what causes inertia. That's the ninth dimension. Gravity is caused by the seventh dimension, which is the compression of space-time. And there is another dimension, the eighth dimension, which causes a whole nother effect, but I'm not going to get into that yet. We're not going to talk about it. But I figured out there's other forces besides gravity and inertia, and some of these forces are caused by the eighth dimension, but I'm not going to get into that yet. But these forces, they're calling them forces, but they are pretty much, that's what they are. I mean, force is something that I guess compels you to do something, whether you want to do it or not. It's a natural compelling. I don't know what maybe I need to look up what the Webster's Dictionary of force is, but if someone pulls out a weapon on you and they're compelling you to do something, that's they're applying some sort of force on you. Or even if it's not a weapon, if it's just some kind of societal force or pressure from your family, or any kind of force. You have different types of force. If someone just wants to use physical force, they're bigger than you or they have more muscles than you, and they're trying to force you. If the police or law enforcement comes, they say, the law says this and that, and whether you want to comply with it or not, we're here to make sure that you comply with the law, and we're here in force to force the law upon you, whether you want to do it or not. So I look at force as something that compels you to do something, whether you want to or not. Now, you can counter force with other force, and you can get into all that, but looking at gravity, you say, well, it's a force. It's a force because you are part of the space-time fabric. The matter in your body is a part of that, interacting with the space-time fabric. And the fabric itself is being forced into a singularity, and you're in an ocean or a river that is flowing in a direction, and you could say the force of that river is bringing you along with it. Now, you can fight against that by trying to swimming against the tide or swimming against the current, but the current is still there, and that's what gravity is. It's a current. We're trapped inside of a giant river that's going to the center of the planet. And that's basically what gravity is, and it's pulling everything down into the center of the planet. Now, if you're in a river and the river is pulling you down to the direction it's flowing, and there's a tree nearby, and you reach out and you grab the tree while you're in the river, you reach your hand up and grab the tree will hold you in place. But the current is still there. So the current goes right by you, and you feel the force of the current pulling you, even though you're holding onto the tree. You're holding onto the tree, the force of the current is pulling you, but guess what? You're not going anywhere. The current is no longer moving you. You're stationary because you're holding onto the tree, which is anchored onto the ground while you're in the river. Well, that's what's happening when you hit the ground on the planet. The ground itself is keeping you in place, but the current is still there going to the center of the planet. And that is time. That force that is compressing to the center of the planet is time itself. It's time. Time is not some abstract concept. It's a physical thing. It's a physical force. It's not just a physical force. It's a physical object that is just as physical as space. Space itself is physical. Time is space operating in a certain way. Space and time are polar opposites of the same thing. Space and time are the same thing. As you look at my chart, you take one thing is built on the other. The longitude thread is built on the latitude thread. It's the latitude thread flipped on its side. And then you have, you know, a neutral position that shows up the z-plane, which can take either position, the latitude thread or longitude thread. That neutral position is neutral. It could become either one of those things. But one is built on the other, and so time is built on top of space because there's a polar opposite. You have time on one end, you have time on one end, space on the other end, or space on one end, time on the other end. They're two sides of the same coin. So why do we treat time differently than we treat space? They're both the same thing, just in a different way. Longitude is latitude flipped on the side. They're both the same thing, just in a different position. Time is the same thing as space, just in a different position, but we treat it like it's something completely different, and it's not. It's the same thing, which means that it has the properties of the position that is before it. So we look at space, the latitude thread, the longitude thread has the same position, has the same properties of latitude, is just flipped on its side. Well, why do we treat time differently than space? We don't need to do that. Time is just like space, it's just in a different position. And it has the same properties that space has, which means that if space has coordinates, you know, you can have points in space. Guess what? You can have points in time also. You have a destination point, right? Where you're going, you have your point of origin. And then if you have a graph, you have, you know, the latitude positions and the longitude positions. And using a graph, you can go up and down, starting from 0 in the middle. You can go up, or you can go negative, or you can go to the right, you know, positive, and you go to the left, negative. But using that graph, you can plot your position in space and a point of origin and a point and a destination point. You can do that in Euclidean space. You can also do that in time. It's the same thing. Only difference is time is the like I said in the last video, you take the ends of a thread or string and connect them. Time is just a line with the ends connected. You loop back around to where you started from. That's all it is. That's why anything that you find in physics is that has either repeating decimal or goes to infinity, that is a wall in space and time. Those are walls. When you have a repeating decimal, or you go into anything in your mathematics that goes into infinity or infinite, that's a wall that you're encountering. And that's what time does to space. It sets up walls and boundaries in space to separate one part of space from another. That's all it is. It's like a structure in space. You have one space, and then you have a structure. You take space, and when you take those threads and you loop them around and connect them, you create another structure. And that structure can be used to create walls because it's a loop. It's an infinite. So you take a line, and when you hit that loop, it's like a cul-de-sac. You're driving down the street, you reach a cul-de-sac. At the end of the street, there are houses there, but you can't do anything but just loop around in that cul-de-sac unless you go back the way you came. That's a wall. That cul-de-sac is acting like time. The street is space, and when you reach the cul-de-sac at the end of the block, at the end of the street, that's time. And you reach the cul-de-sac, you can't go anywhere but go loop it back around to where you came from. If I take a ball and throw it against the wall, a bouncing ball, I throw it against the wall, it hits the wall, but where can it go? It's like a cul-de-sac. It can't go any further. It's got to come back in the direction where it came from. That's what time is doing in space. If you can't go any further, guess what? It sends you back the way you came.